Today we discussed about graph traversal. What is meant by a graph? Graph is a nonlinear data structure. What is graph traversal? Traversal means visiting all the nodes in the graph. In traversal, traveling around all the nodes in the graph. In graph traversal, we can select any node as the starting node. Based on that starting node, we can visit all other nodes in the graph. In graph traversal, consider two terms. One is visiting a node and other is exploring the nodes. Visiting a node, that means visiting a particular node in the graph. Exploring a node, that means visiting all the adjacent nodes in the particular node, that is exploring that node. In graph traversals, two methods are there. First one is depth first traversal and breadth first traversals. In depth first traversal, it uses stack data structure. Breadth first traversal use queue data structure. In the breadth first traversal, it visiting based on depth. We can select one node as the starting node. Then, from based on that starting node, depth search first. Again, search depth first. Like that, all the nodes are visited. That is depth first traversal. In breadth first traversal, it uses a queue data structure. It also searches based on a particular level. All the nodes in a particular level is searched or visited first. Then go to the next level. That is the method of breadth first traversal. First, we consider depth first traversal. In depth first traversal, use stack data structure. So many backtracking are there. In backtracking methods are used in depth first traversal. Let us consider this example. It is a graph that consisting of 7 nodes, that is V0, V1, V2, V3, V4, V5 and V6. This is a direct graph. In depth first traversal, use stack data structure. So push and pop operations are used. In this graph, we can select any node as the starting node. So we can start with V0 as the starting node. Then V0 is pushed into the stack. Then based on the V0, the adjacent nodes of V0 are visited. That is V1 and V4. This is also pushed into the stack. Then V1, V4 also pushed into the stack. Then we can select any one of the node from that. That is V4 or V1. Then we can select V1 as the node. Then the adjacent node of V1, that is V3. Adjacent node of V1 is V3. So that is V3 is pushed into the stack. So V4 and V1. Next one is V3 is selected. The adjacent nodes of V3 are V6 and V5. So V6 and V5 is pushed into the stack. The stack content is there V4, V6 and V5. Then let us consider the node V5. V5 is the terminating node. All the adjacent nodes of V5 is also pushed into the stack. Then V5 is popped from the stack. That is V4 and V6. Next, we consider V6. All the adjacent nodes of V6 is also visited. So V6 also popped from the stack. Next, we consider the node V4. All the adjacent node of V4 also visited. So V4 also popped from the stack. Then stack is empty. Stack empty is the termination condition of depth first structure. It uses a stack data structure. Some patterns of traversals are obtained. Some vertices are not pushed into the stack. Some vertices are pushed more than once into the stack. This is a specialty of depth first traversal. In depth first traversal, it uses a pre-order traversal of a tree. Like that, depth first traversal is worked. In breadth first traversal, it is typically short and bushy. In depth first traversal, is long and tiny. Next one is breadth first traversal. In breadth first traversal, it visited a level by level order. All the nodes in level I is visited before the nodes of level I plus 1. Let us consider this figure. In this figure, 0 is noted as the 0th level, 1 is next level, 2 is the next level. For all the nodes of 0th level is visited first. That is 0 level nodes also visited. Then go to the first level nodes. All the first level nodes are visited. Then go to the second level nodes. Like that, level by level traversal is there. In breadth-first traversal, it uses queue data structure. So level by level traversal, then all vertices are visited into the all the vertices are entered in the queue exactly once, and all vertices are once inserted in the queue. In this case, two patterns are obtained based on traversals. Based on we can select left subtree or right subtree first. Like two patterns are obtained. The termination condition of breadth-first traversal like DFS, it is QMT. It uses a branch and bound technique in breadth-first traversal. Let us consider the same example. The same graph, 7 nodes, V0 to V6. First we select any one of the node as the starting node. V0 is also the starting node. V0 is inserted into the queue. Then the adjacent nodes of V0, that is V1 and V4, that is inserted into the stack. So first level nodes are inserted, then go to the second level. Then based on the vertex V1, that is a second level nodes. All the second levels are visited, then go to the third levels. Based on V1, go to next adjacent nodes, that is V3. V1, then go to V3. So inserted V4 and V3. V3 is the adjacent of V1. Then let us consider the adjacent of V4. So level 2, V1 and V4 are level 2. So first consider V1, then go to V4. Anyone we can select first V4 or V1. And then the V4 is the terminating node. So second level is completed. So V4 is deleted from the queue. Then consider the V3. V3 is the third level. So all the third levels are visited. The adjacent nodes of V3 is V6 and V5. This is inserted into the queue. Next we will consider V5 or V6. Or in V6, all the nodes, adjacent nodes are inserted in the queue. So V6 is deleted. Then consider V5. All the adjacent nodes are inserted. So V5 is deleted from the queue. Then finally queue is empty. This is the final condition or terminating conditioning of DFS.